Hi. Yesterday we talked about how to graph points in 3 dimensions. Today we're going to discuss how to graph planes themselves in 3D using the XYZ coordinate system. The general form for any plane in 3 dimensions is the following: AX plus BY plus CZ equals D, where of course you have, when you look at the graph system, you have the X, the Y, and you have the Z-axis going up. Now I know sometimes in physics they do it this way. They'll do what is this? X, Y, and Z coming out at you. The idea is the same. Just make sure you label your axes, okay, so the reader can understand if you understand how to graph these. Remember we talked the other day also about how we came up with the equation for a plane. It's a really good lesson for you. You guys want to go take a look at that again, like my video. All right. So today we're going to take a look at how we sketch the plane. And the easiest way to do is we are going to find the X and Y and Z intercepts, just like you would graph a line back in Algebra 1. 2, we're going to draw the traces. Now trace is a very cool word that we use in mathematics. These are the lines of intersection of when the planes meet the coordinate planes. Traces are basically the line segments. Like if I have a line connecting the X and Z axis, that is called a trace. And then we're going to show the plane with a little bit of shading. And I'm not talking about like insulting your friend type of shading. Question number 1. We want to sketch the following graph. So let's go and take a look here. The first thing we're going to do is we're going to find the x-intercept. And we can do this pretty much in our head. If you just let y and z be 0, I'm going to get x equals 6. So on the x-axis, we're going out to 6. 1, 2, 3, 4, whoops, ran out of room, 5, 6. There it is. On the y-axis, if I look for the y, we're going to let x and z be 0. So I just cover them up, and of course we get 4. So we can go out 1, 2, 3, 4, and I can draw these already. Remember, that's our first trace. It's just the intersection. Now they do kind of go on forever, but we're just going to show the part that we can't really see in the first quadrant, so it's a little bit easier to see here. In the z-axis, we let x and y be 0, and we're going to get 3. So we go up 3. 1, 2, 3. And I can draw my next trace. And I connect those all around. And if you notice, what we kind of get here is a triangle in the first octant. Remember we talked about the other day that when you're graphing in 3D, if you don't have a quadrant, we have an octant. The 4 quadrants that we're normally used to dealing with is the XY quadrant that's down here on the ground. It's like the ground, okay? But now we're dealing with the air, so we actually have 8 spots to it. 4 on top, 4 on bottom, and we call those octants. So the first octant, that's what this is a little triangle. So I'm going to kind of shade that plane right there. That's what I'm going to color in here, and we get our first plane. So let's see if you can try number 2. If you want to, pause it, okay, and try this one. I'm going to go ahead and go on. So we look at the x. Of course, if I let the first 2 be 0, the y and z be 0, we will get 5, 0, 0. Same thing for the y. If I let x and z be 0, we get 0, 5, 0. And the z, we would get 0, 0, 5. And I can sketch those. Every one's a 5, so on the x is 5. 1, 2, 3, 4, 5. On the y, 1, 2, 3, 4, 5. And on the z, 1, 2, 3, 4, 5. And I draw those segments. I draw the lines connecting them. Now these do go on forever, okay? And there is our plane that we're looking at right here. Easy to graph. Later on this year, we are going to calculate the area of this triangular pyramid right here using calculus. It's really kind of cool. Okay, it's really kind of a fun thing to do for us later on this year. All right, for question number 3, graph x equals 2. So let's take a look at this. This is kind of an interesting one. It only has an x-intercept, and that's going to be 2, 0, 0 over 2. Notice there is no y or z coordinate, no y or z intercept. So there is no y or z intercept. So what does that mean? Of course, that means it will not intersect those. Will not intersect those. So if I try drawing it, what we're going to wind up with is a plane. And I have a hard time drawing these, so just do the best you can. So I'm going to start right here. I'm just to have a plane that's kind of look like this. Now, like I said yesterday, you want to think parallelograms when you sketch these. Okay? And what we wind up with is a plane. A plane parallel to the YZ plane itself. So here's my YZ plane. What you wind up with is another plane just parallel to it. It's kind of like if I drew the line in one dimension. We talked about this the other day. In one dimension, if we draw x equals 2, that's just a point, right? In 2 dimensions, we would get a line x equals 2. We would get a horizontal line parallel to the y-axis. It's going to be parallel to the y-axis because there would be no y-intercept there. The same thing is true for planes. Because there is no y or z coordinate here or intercepts here, we know it's going to be parallel to the YZ plane. Pretty easy to get. All right, so let's try number 4 here. For the x-axis, that's just going to be easy. That's just going to be 4, 0, 0. For the y, oh look, there is no y. Therefore, none. This does not exist. It will not cross the y-axis. It does not cross the y-axis. For the z, 0, 0, and that should be negative 3 because we're going to divide by negative 4 this time. So my first point, 0, 4, 1, 2, 3, 4. Don't forget going outwards is positive. Negative 3, 1, 2, and 3. Now this one's kind of tough right here. And if I connect them, take a look if I connect them. Again, we're going to get a plane. But remember, this plane will not touch the y-axis. So we're going to get a plane not touching the y-axis. Alright, these are hard to draw, so you guys are probably be better at this than I am. I'm terrible at drawing these things. So think parallelograms. So I'm going to go parallel to Z, and I'm going to go down like so. And there we get our plane. Not touching the y-axis. Matter of fact, if you notice, now be careful, this does go in towards the Z. So I'm not really good at drawing these, okay, my best right here. But you got to imagine kind of like a plane going like this. It's just going to go never touching the y-axis right there. Alright, so let's take a look. So I'm going to go and stop here for right now. And we're going to move on to the next example. And if you go to the next page, we're going to talk about some examples of writing the equations of planes again. So you might want to take a look at those again too. Okay? Bye-bye.